Okay. Hi, good evening, everyone. Welcome to the first official lecture of our MA Economics classes. Now, the first topic that we are going to go ahead and begin today, that is going to be consumer theory. Make sure that you write everything down. Whatever I am writing, you should be writing that thing down, and make sure that you make proper notebook for microeconomics. So we will be going ahead and we will be, am I audible now? Give me a yes, no. Okay.
Yes, ma'am, you're audible.
Okay, thank you. Okay, so make sure that you go ahead and keep one copy for microeconomics. You write down the class notes there, you solve the problem sets in the same notebook, and you go ahead and do all the weekly test also in the same notebook. It will be very, very useful for your final revision that you do, because you would not have time to go through 60 hours of lectures that we have at the end. It would be very useful that you go through all these lecture notes later on. Fine. So the first topic of our discussion is consumer theory. And to start with, let us try to understand what is a utility function. See, the most simplest utility function that we go ahead and we study, that is called as Cobb-Douglas utility function. Now, why is it named Cobb-Douglas? Because it was actually introduced by two economists. One was Cobb and other was Douglas. So that is why it got the name as Cobb-Douglas utility function. This Cobb-Douglas utility function has a general form x to the power alpha, y to the power beta, right? To begin with, what we can just assume is that our alphas and betas are both 1. The power need not be 1. The power can be x to the power 2, y to the power 3, x to the power half, y to the power half, x to the power 3 by 4, y to the power 7 by 4, anything. Just that for now, we are assuming that our alpha is also 1 and our beta is also 1. This is just an assumption that we are making. Now, we need to go ahead and introduce the concept of indifference curve also. And what is an indifference curve? Whenever we talk about different combinations of two goods, good X and good Y, such that they give you the same level of utility, they give you the same level of satisfaction, then that forms an indifference curve. So I need to make sure that the level of utility that I have or satisfaction that I have, that is the same, right? Now, it is very interesting if you go through the concept of how the word utility was developed. And you would be amazed to know that the word utility was actually used initially by an English philosopher. Right? And he used the word utility very, in a very general way. He just said that, you know what, the satisfaction or the pleasure that one gets from a commodity, that is utility, right? Then later on, economists picked up on this word and they started using this word for the purpose of economics. But shuru mein, it was an English philosopher who kind of used the word utility. I am leaving it to you. Go ahead, take a day, post it in the group And if you know, post it in the chat now as to who this English philosopher was. I will take this up in the next lecture. I will give you the name for it if you're not able to tell. So just search for the English philosopher who first used the word utility, right? Okay, coming back to the concept. So utility, so indifference curve is different combination of good X and Y holding the utility or satisfaction at one level. Let's say, for example, I tell you that my U is equal to XY. Yes, you're right. That was Bentham. Correct. Absolutely. So the name of the philosopher was Bentham. Yes. Okay. So let's say that the utility function I am using is XY and I hold utility constant at 4. So what can I go ahead and do? I can just take different combinations of X and Y such that I need to get 4. So I can have X as 4, Y as 1. I can have X as 1, Y as 4. I can have X as 2, Y as 2. So 4 into 1 is 4. 1 into 4 is 4. 2 into 2 is 4. Go ahead, X as 16. Yes, by 4. Okay, so I can go ahead and I can have X as 16 and Y as 1 by 4. I can have X as 1 by 4 and Y as 16 and so on and so forth. Different combinations of X and Y so that you get your utility at 4. Now, here in maths, there is a concept I would like to introduce right away that is called as the concept of level curve. Very, very important concept coming from the point of view of maths. Try to understand this. See, what is a level curve? Suppose I tell you Z is some function of X and Y. Let's I tell you Z is equal to X plus Y. Then as I will change the value of X and the value of Y, the value of Z will also change. Let's say I say X is equal to 1, Y is equal to 1, Z will be 2. X is equal to 2, Y is equal to 3, Z will be 5. So I am going ahead and I am saying that I have some combination. Maybe there is some issue from your end because I think everyone, for others, I am audible. What you can do now, just try to rejoin or try to see if somehow you have kept, your speaker low. Huh? Okay. So different combinations I am giving of X and Y and I'm getting different values of Z. Now, this is a 3D diagram that I'm going ahead and getting. So if you try to just see here, just notice that if I take X here, Y here, Z here, let's say I take X to be 1. I take Y to be 1. So when X is 1, Y is 1, I get Z to be 1. Let's say I take X to be 2. I take Y to be 3. So when X is 2, Y is 3, Z will be somewhere here. It will be 5. So what I'm getting is a 3D kind of plot. Now, very same is the concept in microeconomics also. So if I tell you utility function is X into Y, I put some X. Say I put X as 2, I put Y as 3. You will tell me your utility is 6. I put X as 4, I put Y as 7. You will tell me your utility is 28. Right? So as you will go ahead and you will change X and Y, you will get different values of utility. But in this way, I will not be able to ever do any comparison, right? I somehow want that this 3D kind of diagram that I'm getting, I have got this 3D diagram, right? That this is X, this is Y, this is utility. You take X as 2, you take Y at 3, you get utility at 6. 1 point. Similarly, you take X at 4, you take Y at 7, somewhere you get utility at 28. You are getting a 3D kind of diagram, which is very difficult to interpret. So whenever we get such kind of diagrams, we want to convert a 3D figure into a 2D figure. And this 2D figure that we get, this is called as the level curve of the 3D figure. And how do we get this? By going ahead and keeping the third variable value fixed. So when we fix the third variable at something, this question even came in CUET, that check if this is a level curve of this. So when I go ahead and I fix the value of something, when I am saying that z is equal to x plus y, this is a 3D diagram. But if I will fix the value of z at some level, I will say z is 10, and I will say 10 is equal to x plus y. Now I have fixed the value that z is 10, and I will get a 2D diagram that this is x, this is y, here you will have 10 and here you will have 10. This line represents x plus y is equal to 10. So when we go ahead and from a 3D diagram, we go towards a 2D diagram by fixing the value of z, that becomes the level curve of this equation. Same is the case with utility functions. So when I am making an indifference curve, in an indifference curve, I am holding utility constant at some level now. So if I am holding utility fixed, so I am just making a 2D diagram. I am saying just give me different combinations of x and y such that the utility is fixed at 4 or at 5 or at 10, whatever. So I am approaching towards a 2D diagram. So I can say that indifference curves are level curves of utility function. And how do I go about plotting them? Very simple. Now that I have a 2D diagram, I can simply plot this. When x was 1 and y was 4, I was getting the same utility as when y was 1 and x was 4, as when both of them were 2. So if I just go ahead and plot them, I will get somewhere here, this will be my indifference curve. And this would represent the utility level of 4. So this is how we can go ahead and we can plot the indifference curve. The important concept is that while plotting an indifference curve, we are going from a 3D diagram to a 2D diagram. Now, there is one more thing that we want to understand here. I can get a utility level of 4 even when I go ahead and I take x as -4 and y as -1. Array, -4 into -1 is also 4 only, na? Why am I not taking that? Because x and y represent consumption. And we need to understand that consumption is non-negative, right? I can only consume the goods either in 0 unit or in positive units. I cannot have negative consumption of commodities. Now, if I need to represent this mathematically, because many times you will simply see things like this in exam. So you will see that they will say that X, it represents a consumption set. By consumption set, I mean it has many goods. So X can represent something like this, X1, X2, Xn. That means I am consuming X1 units of good 1, x2 units of good 2 and xn units of good n. This is my consumption set, right? So I must have 0 or positive values. Consumption cannot be negative. So I will say that this x belongs to R, and I will write a plus here and n here. Try to understand this thing very carefully. This plus means that it can only be 0 or positive. And this n means that I have n goods in this bundle that I am consuming. If I will write 2 here, it means that there are only two goods, good 1 consumption and good 2 consumption. So the superscript represents the number of goods that I am talking about. And this plus sign represents that either it can be 0 or anything positive, right? I can include 0. I am including 0 or anything after 0 till infinity, but I cannot have negative consumption. So a consumption set is always drawn in R plus space, which means that I am always drawing in my first quadrant, right? Where both the goods need to be positive. So this is positive, this is positive. This is my first quadrant. This is how my consumption is defined. How about prices? Now try to think. It is very, very rare that anything will be available free of cost. Air is free. I can get air for free. If I go to a mountain, I can see that mountain for free. I can get some scenic beauty for free. But anything that is traded in the market traded good, that is not free. It has some price attached to it. So if it has some price attached to it, it means that when I talk about the prices, it even does not include 0. It must be strictly positive, right? I will talk about some free goods very, very late in our lectures when I talk about general equilibrium. But for now, we will assume that prices are strictly positive. So such case, price is represented by R plus plus. 2 plus means that you are not including 0, right? So your price belongs to R plus plus space, which means 0 to infinity, positive, and 0 is also not included. It cannot be 0. We are not talking about free goods, right? Free goods have some of their own complexities. We will talk about them, but not now. Not now, it is not required, right? So this is how we can represent consumption bundle and prices. Now, when we talk about the concept of utility, there are two main concepts under it. One is cardinality. One is ordinality. When we talk about cardinal concept, it simply says that utility can be measured. And its unit is utils. So it says that we can go ahead, we can measure utility. The units of utility will be utils. And this goes ahead and it says that we have something which is known as law of diminishing marginal utility. So it says that as you keep on consuming a commodity, the additional utility that you will be getting from that commodity will continue to decline. right? So if I consume the first unit, my extra utility from that can be 10. I consume the second unit, my extra utility from that will only be 7. I consume the third unit, my extra utility will only be 5, so on and so forth. That will keep declining. So my total utility will increase, but at a decreasing rate, right? My total utility is 10 here, 17 here, and 22 here, and so on and so forth. Now, in this law of diminishing marginal utility, we actually go ahead and we define a satiation point. Satiation point is defined as that point where your marginal utility becomes 0 and your total utility becomes maximum. So if I were to go ahead and draw this graphically in very, very simple language, it would be like this. This is marginal utility. When it becomes 0, exactly at that point, my total utility would be maximum. And this would be called as the point of saturation. Right? But this concept that we have here, this has a lot of limitations, a lot of limitations. So it goes ahead and it assumes that marginal utility of money is constant in the background. So marginal utility of money basically represents the extra utility you get when you get an extra unit of money. Now just imagine. Suppose I tell you that you have 100 rupees and I give you 10 rupees more. And in another scenario, I tell you that you have 5 lakh rupees and I give you 10 rupees more. Will you get the extra utility and this case the same? No, it's not possible. When you already have 5 lakh rupees, the extra 10 rupees will give you very less utility. But when you have 100 rupees, the extra 10 rupee will give you more utility. So we cannot assume that the marginal utility of money is constant, that it remains the same. As you continue increasing the amount of money, the additional utility you get should decline. Money should be treated like any other good. But when we talk about the concept of cardinal utility, again, a very often asked question in MCQs, that this is one of the very basic assumptions that we assume marginal utility of money to be constant, which is not correct, but we assume it. One last thing here. So under cardinality, we have something which is known as law of equi-marginal utility. This law suggests that in single commodity, your equilibrium is where MUX by PX is equal to MUM. And in multi-commodity, your equilibrium is MUX by PX is equal to MUY by PY is equal to MU. What does this mean? So MUX by PX basically asks you what is the extra utility you get by spending the last rupee on good X. So whatever last rupee you have, if you spend that on good X, I have one last rupee left with me. If I spend that on good X, the extra utility I will be getting, this is this figure. And it says it should be equal to the extra utility you get when I give you an extra 1 rupee. Let me reiterate this thing. So this says that suppose you just have 1 rupee left and you spend that on good X. The extra utility you will be getting. This is this side. This is telling you that suppose I give you extra 1 rupee, I give you 1 rupee from my side. What is the extra utility you will be getting? And this says that at equilibrium, both of them should be equal, right? Oh, you should have told me earlier. What is not visible? Tell me. Is this visible? Because I think I can, others. It should not be the case that webcam covers it. Maybe you are using via phone. Okay, 1 second. Tell me now if it is better now. I think some of you have a different version of Zoom, because when I am looking at it, I don't see my image in the overlapping with the video. Is it fine now? Okay, I hope this is better now. Fine. Okay, so what I am saying is that this is the extra utility you get by spending the last rupee. And this is the marginal utility of your money, the extra utility you get when I give you 1 extra rupee. Both of them would be equal. Not sure, yeah. Earlier it never happened. I think this is due to some versioning issue with the Zoom, if you face some issue. I think now it should be fine. I have removed all possible, whatever editing Zoom had. I've removed everything now. There is no editing left. Okay. Just recently, 15-20 days back, they have changed this version. Okay, fine. So now let us go ahead and talk about the law of equimarginal utility for two goods. So when we talk about two goods, it says, the extra utility you get when you spend that last 1 rupee on good X should be the same had you spent that last 1 rupee on good Y. And it should be the same if I give you that last 1 rupee and I ask you what is the utility you get. This is the law of equimarginal utility, also called as Gaussian's law. Many of you have to now understand that we are dealing with some theoretical questions also. We may be asked this in GATE, also in IIT, also in CUET, right? So it has become a little theoretical also, and we need to remember these things. So when we talk about law of equimarginal utility, for single commodities, it says MUX by PX is equal to MUM. And for two commodities, it goes ahead and says MUX by PX is equal to MUY by PY is equal to M. Now, coming back to the concept. So now let us go ahead and let us talk about ordinality. This is what we want to deal with. Ordinality basically comes from the word ordinal. Ordinal means ranking. So when we talk about ordinality, ordinality simply goes ahead and negates the concept of cardinality. It says we are not concerned with measuring utility. It cannot be measured. Rather, we would like to go ahead and understand which bundle is better. So if you go ahead and you tell me that, X gives you utility of 10 and Y gives you utility of 1, it means that X is preferred over Y. And if you go ahead and you tell me X gives you utility of 10 and Y gives you utility of 9.99999, then also X is preferred over Y. So ordinality says, I am not concerned whether we have this case or this case. I am not concerned with numbers. I don't care what this number is. I just want to know, if I give you two bundles, X and Y, will you prefer X or will you prefer Y? That is what I want to go ahead and understand. And that is the entire scenario that we have. So ordinality just negates the concept of calculating utility and giving numbers. It simply tells that let me know the ranking between bundles. Just tell me which bundle will be preferred over which bundle, and that is enough. Once we deep dive into the concept of ordinality, we begin with something which is known as axioms of rationality. But before we do that, I want to explain to you who is a rational human being. According to economics, any human being who is maximizing his utility, who is maximizing his own satisfaction, who is interested in his own consumption, right? He is a rational human being. The opposite of rationality, Snyder takes an example and explains in his book, the opposite of rationality is altruism or an altruistic consumer. He is a consumer who is very happy with welfare of others. Maybe our parents. They are more concerned about welfare of children rather than taking decision for their own welfare. So we can say that parents are altruistic in nature, but maybe if we take care of our preferences, our satisfaction, then we are rational. So if I talk and I want to write this mathematically, an example of rational human being can be when I say utility of individual A is equal to XA, YA. So we are saying that utility of individual A depends on the consumption done by him. How much of good X and good Y he consumes. So he is rational. But if I go ahead and I say that utility of individual B is equal to XA into YB. Now this is tricky. Individual B is basically, it is part of ordinality. But जो भी अब हम करेंगे throughout, everything is ordinality. We will only be talking about ranking bundles. Cardinality is I can say it's a gone topic. मतलब, no economist will ever use cardinality in his concept. Everything falls under ordinality now. Okay. So when I talk about this utility function, what is this saying? Utility of individual B is affected by the consumption of good X of individual A. Like typical, I can tell you my mother, your parents, So as long as I will not go ahead and have food, maybe she will not be satisfied. She will keep thinking that, did she have food? So if I go ahead and I take this as good X as food of individual A, so utility of individual B can be impacted by food of individual A. This is an altruistic consumer. We are dealing with consumer who are rational, who want to take care of their own satisfaction, right? Who want to just consider their own welfare. That is a rational human being. Now, whenever we talk about a rational human being, we come across certain axioms that we have to follow. And the first axiom that we have, that is called as completeness. Completeness, before I do completeness actually, just some notations I will explain you so that you can understand these axioms. This stands for strict preference. So when I say that X and then I use this sign and then Y, it means that X is strictly preferred to Y. It means that the utility from X is clearly more than the utility from Y. This is how we can go ahead and write this. So whenever X would be strictly preferred to Y, it will mean that utility of X will be strictly more than utility of Y. The next sign that we have, that is this. This stands for weak preference. So when we say weak preference, X weakly preferred over Y, it means that the utility from X can be equal to or more than the utility from Y. So weak preference includes all kind of bundles. It includes bundles which give you more utility, but it also includes bundle which go ahead and give you the same level of utility. The third sign we have is this sign. This means the sign of indifference. So when I say X and then I use this sign and Y, it means I am indifferent between X and Y. So the utility from X and the utility from Y must be equal to each other. Many times in exam, this is represented with X, P, Y. X is strictly preferred over Y. This is represented with X, R, Y. X is weakly preferred over Y. And this is represented with X, I, Y. That means I am indifferent between X and Y. These three signs and these three notations you need to remember because they would be used very, very often in exam. If I want to go ahead and I want to show these three on an indifference curve, so how can I go ahead and show this? So if I tell you that this is an indifference curve, then all bundles on indifferent curve, I should be indifferent between them. They should give me the same utility. So bundle A, bundle B, bundle C, the utility that I get from them, it should be the same. If I get the same level of utility from A, B, and C, it should mean that I should be indifferent between A, B, and C. This is how I can show the first thing. I can say A, I, B, I, C. Now, if I go ahead and I take a bundle above my indifference curve. So this is my indifference curve. And I take a bundle above my indifference curve. This is bundle A, this is B. And this bundle will lie on a higher indifference curve. Right? So suppose this indifference curve represents that my utility is 4. This will represent maybe my utility is 5. This bundle can be 2 and 2. 2 into 2 is 4. So this represents 4. This bundle maybe can be, say, 2.5. Suppose let me just take it here. It can be, say, 2.5 and 2. This bundle can be B. So bundle B clearly has a utility of 5. My utility function is x into y. This is 2 into 2, 4. This is 2 into 2.5, 5. So clearly I know that bundle B is giving me more utility than bundle A. So B should be preferred over A. So B, P, A. P represents strict preference. Bundle B is preferred over bundle A. And if I include all these bundles together, that means I am including all bundles on the indifference curve and all bundles above the indifference curve. Then that space represents my weak preference. Why weak preference? I have included all bundles which are on the indifference curve. And I have included all bundles which are above the indifference curve also. I have taken all this shaded area. So because it includes all bundles between which I am indifferent by including bundles on the indifference curve, and those bundles which are preferred by including bundles above the indifference curve, I have made a weakly preferred area. So weakly preferred region is IC and above IC. Indifferent is just my IC. And strict preference is only above IC but not IC, not indifference curve. Only the region above indifference curve represents strict preference. So an indifference curve can be used to analyze all these 3 regions. Okay, now let me just come back to what I was teaching you. Let's talk about completeness. Completeness, as the word suggests that your preferences should be complete. And by complete, I mean that they should be comparable. I should be able to go ahead and compare. I should be able to say that when I give you 2 bundles X and Y, do I prefer X over Y? Or do I prefer Y over X? Or am I indifferent between X and Y? I should be able to make that decision, right? I should be able to tell you my preference. That do I prefer X over Y, Y over X, or am I indifferent between X and Y? What exactly I want, that should be absolutely clear in my mind. That is basically called as completeness. Can you go ahead and tell me a violation of completeness? When completeness would be violated? Anyone? when can completeness be violated? So, yes.
And x is equal to y.
That is also not completeness. I mean, it's not violated. Because you are able to tell na, that, okay, I prefer x and y equal. So you are able to make a decision. Then completeness is not violated.
When two indifference curve intersect each other?
That's not okay. So when two indifference curve intersect, that is actually incorrect only. I mean, two ICs cannot intersect only. So if they intersect, it means that we are doing something wrong. But when we go ahead and we write these axioms, जब भी हम ये axioms लिखते हैं, in the background we assume कि वो सब satisfied है, that ICs will never intersect. They will be like these. They will not connect with each other. ये चीज हम assume करके चलते हैं. Okay, this is good. So I like this example.
Complementary goods.
Sorry, when
Complementary goods.
complementary goods, again, they follow completeness. You can go ahead and you can tell, right, that I want both the goods. You can tell I want pen also and ink also. So when you can tell, it completeness is there. I liked this example of life and death, but I mean, somehow everyone would want to live, right? So why would you be I mean, you can make a choice that I want to live. So not sure, but this example is a perfect one. Yes, yes, absolutely. This is one of the example that, I kind of give every time. So it is the example of relationships. You're right. So for example, if let's say I ask you that, you have a boat in which you have your mother and father, and you can only save one of them. Or I ask mother that you have two children and you can only save one of them. तो उस टाइम पे डिसीजन नहीं लिया जाएगा, राइट? Nobody will be able to make a decision. So usually when you have to go ahead and you have to choose in relationships, that is where your completeness will be violated, because wahan pe you will not be able to choose. So violation means where you cannot choose. You cannot tell. If I ask you, do you love your mother more or father more? Or, whom do you want to say? So you won't be able to tell any answer for it. So where no answer is available, you cannot tell mother over father, father over mother, or mother indifferent to father. You can only save one of them. And you cannot tell whom you want to save out of the two. So in that case, when there is no answer available, that is a violation of completeness. Right? Very good. Yes. Good. Yeah. Understood. Yes. This is a good example, whether you want to die by gunshot or fire. Yes. None, huh? And IGIDR or IIT, I will tell you which one. Don't worry. We will choose. Okay. So this is the first thing, which is completeness. The second one that we have, that is transitivity. Okay. Why gunshot? Not sure. Okay. Transitivity. Transitivity says that if I prefer X over Y and Y over Z, then X should be preferred over Z. Very often question asked in exam. That if I write XPY and YPZ, then I should be writing XPZ according to transitivity. Right? I should be writing XPZ according to transitivity. Similarly, if I am indifferent between X and Y, and I am indifferent between Y and Z, then I should be indifferent between X and Z. So X, I, Y, Y, I, Z should give me X, I, Z. Same goes with the last one. If I weakly prefer X over Y and I weakly prefer Y over Z, then I should weakly prefer X over Z. X are Y, Y are Z, then X are Z. This is called as transitivity, right? And a very, very simple example I will give you. So if I have a bundle which is 1, 1, and my utility function is X into Y. So here my utility will be 1 into 1, which is 1. Now, if I give you another bundle, so this is 2, 2, my utility is 2 into 2, it will be 4. Clearly, I see that utility from Y is greater than utility from X. So Y is preferred over X. Similarly, suppose I give you a bundle 3, 3. My utility will be 3 into 3. That means 9. So my utility from Z is more than utility from Y. So Z should be preferred over Y. So I have Y preferred over X, Z preferred over Y, and clearly I can see that utility from Z is more than utility from X. So Z should be preferred over X. This is an example of transitivity. X preferred, Y preferred over X, Z preferred over Y, so Z preferred over X. Now, can you go ahead and give me an example of when there will be violation of transitivity? Anyone? When will transitivity be violated? Okay, children case. Yes, that's possible. So, you're right. Usually it also happens with children. So for example, if I tell children that, okay, I have say Kit Kat and Munch and let's say Snickers, right? Then children may prefer Kit Kat over Munch over Snickers. So इस हिसाब से तो Kit Kat should be preferred over Snickers, but they may prefer Snickers over Kit Kat. Right? So with children, we don't know. They may go ahead and they may violate transitivity. Correct. Right? So this is an example of violation of transitivity. But there is another example, and that is what we use in the case of economics. That is called as the voting paradox. So when I talk about voting paradox, we will be talking about this not now, but when we go ahead and we do welfare economics. For now, just remember, in voting paradox, what will happen? If I give people choice to choose between party A and B, they will choose party A. Between party B and C, अगर मैं उनको choose करने को बोलूं, they may choose B. So according to this, when given a choice between A and C, they should choose A. But they will do the reverse. When given a choice between A and C, they may choose party C. So these kind of preferences, they are called as cyclical preferences. In cyclical preferences, there is no conclusion. You are choosing A over B. You are choosing B over C, but you are choosing C over A. So finally, which party are you choosing? Which is the right party? We don't know, right? So such kind of preferences, they are known as cyclic or cyclical preferences, which violate transitivity because we don't have one particular answer or one particular party to go with. That's my second assumption that I have. Third assumption. This is known as continuity. Okay. Now, what is continuity in the field of maths? Right? In the field of maths, very, very simple language, continuity is, I pick up a pen, I start drawing something from it. If I have to pick up that pen from the notebook and again put that pen down, it means at that point it will be discontinuous. So take this. Now I will start drawing a curve. If I have to pick up this pen and again draw, then at that point, it must be the case that the function must be discontinuous. That's a basic way how we check continuity or discontinuity. Same is the case with indifference curves. So for example, I will dedicate one full lecture on discontinuous preferences. One example of that is lexicographic preference. Maybe just 3-4 lectures after today's lecture, we will do this lexicographic preferences and we will talk about how they are discontinuous. Right? So for now, let me give you an example. Let's say I have this indifference curve. This is good X. This is good Y. As of now, this indifference curve is, let me explain better. So as of now, ये indifference curve continuous चल रहा है. Throughout, it's a smooth curve that is going on. Now what I am doing, I am saying that look, throughout the utility of this indifference curve is 4, but just at point 2, 2, जब हम point 2, 2 reach करते हैं, at this point, the utility of this function is not 4. Right? Throughout the utility of this function is defined, it is 4. But the moment you reach the point 2, 2, I am saying that at this particular bundle, the utility quickly increases to some other level. When we go ahead and we create a hole like this, in the indifference curve, there is a point at which utility is not defined on the indifference curve. That basically represents the point of discontinuity. For example, let's say my indifference curve is x minus 7 into y is equal to 10. This is my indifference curve. This is my IC. And I start solving this. Right? So what I am going ahead and doing, I am just finding the value of y. Y will be, this is my level of utility. I am holding utility constant at 10. Right? I start solving for y and I get y is equal to 10 upon x minus 7. Now, we know that mathematically, anything which is in P by Q form, any rational number, we know that the denominator cannot be 0. So we know that this is defined throughout, but x minus 7 cannot be 0. So x cannot be 7. So I can plot it everywhere, but I need to just make sure that x minus 7 cannot be 0 or x cannot be 7. So at x equal to 7, I will say that this is a point of discontinuity in my utility function or indifference curve. So discontinuity simply goes ahead and means that your function is not a smooth curve. It has some points which are which are away from your ICs. There is another example which is given in variant book, and this is about discrete goods. So imagine that if I take good X Good X represents the number of cars that you buy. And good Y just represents your money on all other goods. Now the number of car that I will buy, it cannot be continuous. It will be discrete. Either I will be buying 1 car, or I will be buying 2 car or 3 car. So with 1 car, I will draw an indifference curve. It can look something like this. This indifference curve says that, look, my number of car is fixed at 1. And based on the moment I go ahead, I don't even need to draw these dots as of now. The moment I fix my car at 1, whatever money I'm spending on other goods, it is giving me some level of utility. Then, when I increase the number of cars to 2, I will have less money left for other goods, right? So maybe I will reach some point here. This point represents that my utility is increasing because the number of cars have increased, but I will be able to go ahead and spend less on other goods. So this bundle just represents the utility I will be deriving from this bundle. These bundles, they are singleton dots. I am not having a curve-like thing here. I am not going ahead and saying that, it's a continuous good, that I can consume cars in fractions also. The moment I make any good as a discrete good, it actually goes ahead, it actually goes ahead and makes my function discontinuous. So what I am saying is discontinuity can arise whenever you don't have a curve-like situation. Whenever you have dots which are not connected with each other, suppose it would have been something like this. Let's say, you are given that you can consume car, but you can consume car in fractions also. 1.1 car is also possible, 1.2 car is also possible, 1.3 car is also possible. Then I would have got an indifference curve like this. That, okay, when I have 1 car and this much money for other goods, this is the utility. And I get the same level of utility if I increase the number of car, but I spend less on other goods. Point A, point B, point C, they give me the same level of utility. But when I make a curve, it actually ensures that I can consume 1.1 car also. I can consume 1.11 car also. It's a fraction that is also possible. This good is a continuous good. I can consume it at any amount, right? So this gives me a continuous indifference curve. But the moment I go ahead and I say that either I can consume 1 car or 2 car or 3 car, but बीच वाला कुछ भी possible नहीं होगा. 1.1 will not be possible. 1.5 will not be possible. Then I cannot have this curve actually. I will only have these dots. Now it's not continuous. Nothing is joining it together. So it becomes a discontinuous function. So when I increase the quantity of both goods, I just wanted to say how we can go towards higher and higher indifference curve. So, this is my IC1. I'm just drawing dotted line, representing that they have same level of utility. And then this can be my IC2. And this can be my IC3. But consumption can only take place on these discrete points. Here, here, here. Consumption cannot take place throughout. It can only take place when X is 1 here, or when X is 1 here, right? So I'm only linking it to discrete consumptions. I cannot have points in between. That is why when you will be looking at books, they will be going ahead and drawing vertical line passing through point 1, passing through point 2, and passing through point 3. Vertical line just represents that you can only go ahead and consume them in these discrete amounts. And each point such that this point, this point, this point gives you the same utility. Similarly, I can say that this point, and this point give me the same utility. This point, this point, this point give me the same utility. So just go ahead and draw an indifference curve. This is good x. X is discrete. This is good y. Just draw an indifference curve. Go ahead and say that this can be 1, 2 or 3. जब x discrete होगा, whenever x will be discrete, you can only consume either 1 unit, 2 unit or 3 unit. So I will have either this point A, this point B, and this point C. A, B, and C will give me same utility. They are on the same IC, but this continuity will not be there, as I can only consume them in discrete amount. Then make another indifference curve. So suppose A, B, and C represent that my utility is 4. Then make another indifference curve. So here I can consume point D or point E, because again discrete amount, or point F. Again, point D, E, and F will give you same amount of utility. But it's not continuous. I need good X only in discrete amount. So either I will be on point D or point E or point F. D, E, F indifferent. Utility can be, say, from D, E, F, it can be, say, 5. This is how we can represent discontinuous preferences. Discrete goods are those goods which can only be consumed in fixed quantities. They cannot be having any decimals up. So usually when we go ahead and we draw an indifference curve like this, we assume that we can consume good in any amount. So for example, if I take good X here, I can consume 1 unit of X, 2 units of X, or anything in between also. I can consume 1.1 unit also, 1.5 units also, 1.8 units also. This means that I am assuming that good X is a continuous good. I can consume it in any quantity, any decimal quantity also. But here I am saying that either X will be 1 unit or 2 or 3, but nothing in between. I cannot have anything in between. That is of course there. Only in, yes, in positive integer numbers, correct. That is what discreteness goes ahead and means. So whenever we have discrete preferences, that is where your continuity will not be followed. Okay, I just want to do one last assumption so that you will be able to do your DPP. Otherwise, you won't be able to solve the questions. So it is reflexive preferences. So reflexive goes ahead and it says that any bundle should be as good as itself. So when I say that bundle X is as good as itself, we write it like this, right? So here we are saying any bundle is as good as itself. For example, if I give you 2 pens, right? Both these pens are Renault pens. Both these pens are blue gel pens. Both these pens are of the same price, 10 rupees. Everything is the same. By looking at these 2 pens, there is no difference. They run the same, they write the same, everything is the same. सब कुछ same है एकदम, 2 pens के बीच में. So if I go ahead and I give you 2 pens, and these 2 pens have everything same, सब कुछ इनके बीच में same है, then we can go ahead and say that one pen is as good as the other pen. There is no difference between the 2 pens. So when the two pens are exactly the same, we will go ahead and say X are X. One is as good as the other. Now, yes, you can say that the goods are homogeneous. That is when we are using XRX. We are not saying that, see, I can be indifferent between two very different things also. You ask me, for people like me, you ask me, you give me two very different cars, I will tell you I am indifferent between the two. Maybe Swift and say some other car. I am indifferent between the two, although they are not homogeneous. So indifference is possible even when two things are different. अगर दो चीजें एकदम अलग हैं तो भी indifference possible होगा. But reflexive says that if two things are same, अगर दो चीजें same ही हैं, तो तब ऐसा नहीं बोल सकते that one would be preferred over other. So when two things are exactly the same, then I cannot say कि I will prefer one over other, right? You cannot say X, I, X. The reason is, again, so we always talk about things in weak preference spaces in this case. The reason is that we may sometimes encounter examples where people may say that, okay, although the two things are exactly the same, I just want to go with one over the other. This is what happens with us as rational human beings. I will give you an example. Many of us go to the shop, and when the shopkeeper gives us two exactly same pen, we ask him to give us a notebook and we try to check how the pen is working. Both the pens are of the same brand, are of the same color, same gel pen, and so on. Somehow your mind may tell you that I will choose this over other, although both of them are exactly the same. So we always talk about weak preferences in case of reflexiveness. We always go ahead and we want to talk about the region on and over indifference curve. So I say, when you give me two goods, I will not say that I prefer one completely over the other. I will say I may weakly prefer one over the other. ऐसा नहीं हो सकता कि if you give me two pens, I will say one is better than other. I will say, okay, both of them look the same, but in your mind, you may have a choice towards one of them. So we always talk about weak preference when we talk about reflexiveness, not indifference, right? So you can go ahead and say that reflexiveness always goes ahead and says about weak preference, right? This is one of the properties of your, or an axiom of your rationality. So weak preference just says that if I give you two things, two exactly same things, then either you will be indifferent between the two, or you will prefer one over the other. When we combine these two things together, we get the concept of weak preference. So weak includes the bundles which give you more utility, and it also includes the bundle which give you the same level of utility. When we include both these kinds of bundles, then what we get is called as weakly preferred region or weak preference. If I only include these bundles, अगर मैं सिर्फ इनको include करूं, in which I am indifferent, which give me same level of utility, then this is indifferent. If I only include these bundles such that utility of X is strictly more than utility of Y, this is strict preference. But if I include all of them together, अगर मैं सारे include कर लूं, all those bundles in which I am indifferent and all those bundles which are preferred, If I take both of them together, then the region I get is called weak preference. So weak preference includes those bundles which are on my indifference curve. And it also includes those bundles which are above my indifference curve. So again, see, when we say reflexivity, we are talking about exactly the same product. Exactly the same product. We will not go ahead and say sub-products, one being Butterflow and other Jiffy. No. Then I am talking about two different products. Then I am not talking about reflexiveness. Reflexiveness says, I am as good as myself, right? So this pen is as good as itself. I mean, I'm comparing the same thing and saying कि ये अपने जितना अच्छा तो है ही, right? So I'm comparing the person with himself. So you don't take two different things. You take the same thing and you say that that good is as good as itself. Good X is as good as itself. Good Y is as good as itself. That is reflexiveness. Again, it is violated with children. So if I give that child, say, two Kit Kat looking the same, he may say, no, 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 मेरे को लग रहा है this is better than the other, right? So that is an example where he is preferring one over the other. Reflexiveness says that Kit Kat 1 is as good as Kit Kat 2. It's the same good. So we are not choosing one good over other. We are just saying, so basically, this reflexiveness just ensures that we are talking about indifference curves in the right way, right? So we are including the entire weakly preferred region. So when we combine all these things together, when we combine reflexiveness plus transitivity plus convexity, which I will be talking about, it just ensures that we are going towards the direction of a well-defined preference. We are able to go ahead and draw, जिसको हम अपना Cobb-Douglas indifference curve बोलते हैं, that Cobb-Douglas indifference curve is called well-defined. I mean, it follows all the axioms well. So we are in a way reaching towards the shape of this Cobb-Douglas indifference curve. Why it looks the way it looks. So in weak preference, we are just going ahead and saying that X is as good as itself. So if I will show you two X's, you can choose any. That is what weak preference is saying. If I give you two Nataraj pencils, you can choose any. One is as good as itself, right? But if I go ahead and I give you one Renault pen and other some air gel pen or something else, then the two goods are not the same. That is where I cannot apply this reflexiveness property. So under weak preference, when you compare the same good, you can choose any. Both of them are the same only. That is exactly what it is. So when in exam, they go ahead and say that individual A has good X, has 2 units of good X, and he needs to choose one of those, right? Let's name the first unit as alpha and second unit as beta. Which unit should he choose to obey reflexiveness? Which unit should he choose to obey reflexiveness? So, दोनों good X ही है. Both of them are same only. So, one good should be as good as the other. So, he can choose any. Good alpha is as good as good beta. Good beta is as good as good alpha. So, choose any now. That is what reflexiveness is saying. If I give you exactly the same good 2 times, and I ask you to choose one of them, you can blindly close your eyes, you can do a lottery system, you can roll out your dice and just pick one of them. So again, I will not, I will not go ahead and say the word indifference. I will always say weakly preferred. I will not say A is indifferent to another. I will always say A is weakly preferred to other because of the way it is defined. It does not go ahead and say that, I'm not going ahead, and it does not say that I am indifferent between the two goods. It says good X is as good as itself. So the word as good as means at least as much as X, or sometimes more also. So you always use the definition of weak preference here. Don't use the concept of indifference, although both can be the same. Okay, so just remember this thing. Take it. Anyhow, so now we have done few of the axioms of rationality. On the basis of this, you need to go ahead and you need to do your first assignment. I will be posting that on the portal just below your class today. I am also going to post one IIT JAM past year question. This is not based on the axioms. This is based on some logic reasoning that came in exam. So you need to attempt that question also. A video solution will be posted for that question. And apart from that, there are some 3 to 4 good questions on the axioms of rationality. Try to go ahead and complete those also. Okay. Okay. Thank you.